John said, my name is Jeff Bonkoski. I'm here to do the presentation. I'd first like to start out by welcoming you from whatever part of the world you're joining us from. Good morning, good afternoon, good evening, whatever the case may be. To give you a little of my history, if you are joining us for the first time, I was originally a career firefighter in a small community just south of the city of Detroit, where I did 27 years with the departments in that area. And through my career, I trained to the level of a hazmat specialist. I was a paramedic, and I tried to learn as much about dealing with some of the high hazard emergencies that firefighters are faced with on a daily basis. And after retiring, I started doing consulting work. And through that consulting work, I thought, hey, in the 21st century, there has to be a solution for some of the hazards that firefighters and industry faces on a daily basis. So with that, I started my search, and it led me to Hazard Control Technologies and the encapsulator agent that we're going to talk about, F500. So hopefully I can give you a little bit of history and make this somewhat of a presentation that can give you some information and some better understanding of, I guess you can say, somewhat the history of the fire department. And through the presentation, we're going to be talking about, like I say, these industrial hazard solutions, the firefighting, the encapsulation, agents. We want to talk about applications. And the big thing today is environment. People are very, very concerned about the environment as well as employee health. So we're going to talk about, hopefully, and cover many different areas as we go through here. We'll talk about the fire control, the flammable vapors and spills and tank degassing. So as I said, my objectives are to hopefully give you a better understanding of, the agents that we use in the fire service, the water that we're very familiar with, the foam, and then, this new technology that hopefully I can give you some more insight on, encapsulator agent. We'll explain, like say, the different and proper applications, percentages, and we'll talk about some of the industries and some of the applications. And I hope to maybe even share some case histories with you. So when we sit there, we start looking at firefighting agents. We're all familiar with water. Water's been used for generations, for decades. And you know what, when we get into larger fires, we need more water. And you know what, water is not always the most effective. And with the large quantities of water that some of our fires need today, we need to start considering, again, that environmental impact, that water runoff, what's in it, especially when we start dealing with some of our industrial applications. When we look at solutions for some of these types of fires, the answer when water doesn't work is foam. And we're going to talk about and discuss, and we'll see some videos on how, in some applications, when foams are used, they don't seem to be effective. And we'll talk about the reason why. But the other thing we need to think about is when we sit there and we start talking about water, and I'll give you an example, let's say lithium ion batteries. What's, the recommendation for a lithium ion battery? And through many of the trainings I did through hazmat, it's mass quantities or copious amounts of water is a term that's used quite often. And what is a copious amount of water? Many areas of the world are experiencing drought conditions. Do they actually have a copious amount of water that they can use on a fire? An example is a Tesla that burned up in Houston, Texas, where they used 30,000 gallons of water. That's, quite a bit of water to be used on a single car fire. So when we sit there, we start looking at a solution. The solution was foam, and foam has been around since the 1800s. When it was first introduced to help extinguish flammable liquids. And the first was by mixing two powders, aluminum sulfate and sodium bicarbonate, and water, and using a foam generator. So when we sat there and started looking at the history of foam, we also understand that there's only 3 application techniques. It's rain it in, bank it on, and roll it. And when we sit there and we start looking, here we have, a tanker truck. And what's one of the problems with a tanker truck? it's a three-dimensional fire. And as you sit there and you start adding water into the tank through a hole, we start, as we know, petroleum products float on water, and we start to cause that fuel to spill out and creating a larger three-dimensional fire. When we sit there and start looking at foams in some of our auto applications, we have magnesium. Okay, so we get into the magnesium, we get into some of the other hazards that are with the vehicles, and we can end up with additional problems. So is foam always the answer? One of the other things we need to look at when we start talking about foam, what does a petroleum product do on water? It floats. And even though we're using a foam product, if we go to the NFPA 11 foam standard and we look at Annex A11 in that standard, it states foam is not suitable for a three-dimensional flowing, spraying liquid fuel fire. What do we have in this situation? You know, we have a fire inside of a plant dealing with a flammable liquid. We make entry, we start using water and foam, the fuel, instead of the foam being able to smother the fire and create that barrier, that separation. Okay, now it gives that fuel a way to travel outside the building, rolling downhill. And in the process, we possibly make a small fire into a very, very large fire. So another great example, I mean, here we have a vehicle inside of a garage using foam. Okay, yes, you know, it's a three-dimensional fire. That gasoline is just flowing on the surface of the water, coming right down the driveway. It's being very ineffective. So we sit there and start to talk now, and let's look at an encapsulator agent, the new technology. Okay, it's covered under NFPA 18A, which is the standard on water additives for fire control and vapor mitigation. And as you can see from here, it's just been revised. The new edition has been released. And as we go through and we start looking, we see that it lists pretty much all classes of fires, A, B, D, lithium-ion batteries, as well as the 3D fires, the types of fires that we just saw videos where foam did not work on. And it works both on the hydrocarbon-based fuel as well as polar solvents or alcohols and ethanols. So currently, the one that we're going to be talking about is going to be F500. So as we go through the presentation, in the presentation, we're going to be talking about NFPA 18A and specifically Section 7.7, which is a qualification test, which the product goes through as part of its QA/QC. And we'll see a video here later on that we'll talk about, and we'll discuss and explain just exactly what it is. But in order to understand a encapsulator agent, you really need to understand how it works. And I'm hoping in the next few minutes to get you a better understanding of how it works and why it works and how it has an effect on some of the case studies and some of the presentation as we get further into it. So the basic building block of an encapsulator agent is that spherical micelle. You'll hear that term quite often. Okay, it's very important to understand how it works with both the polar and non-polar and hydrocarbon liquids as well as vapors. And I always, often when I do these, ask the question just to get some thought going is, can you name any other fire suppression agent in the fire service that works on a flammable vapor that's a water-based product? And here we're going to see that with an encapsulator agent, this can also work on those flammable vapors as well. So we'll be covering all these different applications, and we'll be looking at multiple applications using one agent, an encapsulator agent, F500, and how it's able to fight today's high-risk fires and help us be able to extinguish them using less water, causing less environmental impact. So to get a better understanding, I hope now to give you what is a spherical micelle. And to understand it, you need to first understand the molecule. The encapsulator molecule has a polar head and a non-polar tail. Polar head loves water. The non-polar tail fears water. It wants nothing to do and wants to get away from the water as much as possible. And here we have a real quick animation.
Encapsulator technology. The next generation of fire and hazard mitigation. First, we start with a simplified version of a single encapsulator agent molecule consisting of a hydrophilic polar head which loves water, dissolves in water, and a hydrophobic nonpolar tail which fears water and will do anything to get away from water. Once the EA molecules enter the water, they instantaneously and automatically orient with the nonpolar tails inward and the polar heads outward, forming millions of spherical micelles. Micelles travel towards and exit the nozzles, forming EA droplets. Micelles nearest to the surface of each droplet automatically break apart. The nonpolar tails orient outside the droplet with polar heads on the surface, forming an EA skin on the surface of every droplet. In addition to the EA skin, there are millions of molecular spherical micelles within each droplet.
So that's a quick animation on the molecule and how it makes these spherical micelles when it gets introduced into the water stream. As you can see, as I
encapsulator
here to the next slide, we could be introduced into the water stream through induction. And when we are introduced into the water stream, the concentrate, when it comes in contact with the water, it creates these spherical micelles. And there's millions and millions and millions of spherical micelles that are created. Again, we see that picture. We see how we have that skin on the surface of each and every water droplet. And what happens is once we get introduced, be it pre-mixed, proportioned using an eductor, however we get into the water stream, when it comes out of the device, be it a sprinkler, be it a fire nozzle or hose, however it's introduced into and sprayed, those droplets now, those molecules, those spherical micelles closest to the surface of the water droplet, they start to break apart. Those tails that want to get away from the water, they spin out and they create that skin on the surface of the water droplet that we see here. So we're putting a skin on each and every water droplet. And when we do that, we're chemically changing the makeup of a water droplet. We're not creating a bubble. Where when we talk about foam and the application of foam, it's a separation of the fuel and the oxygen. That foam blanket, it breaks down. Okay, we lose our protection. If we walk through it, we disturb that blanket, we lose our protection. When we talk about a spherical micelle, and we talk about that water droplet, we're going to talk a little bit more now about encapsulation. And to help you understand encapsulation and how encapsulator agent works, we'll look at this NFPA 7.7. It's not truly the test, but it gives you an idea of what the test is. And the test involves taking a gallon of a flammable liquid, okay, 16 ounces of a concentrate, F500, and then adding minimally 5 gallons of water. Okay. The next is kinetic energy. So when we sit there and we start adding the water and we get that agitation going, that's the kinetic energy that's needed to help complete the necessary, I guess you can say, mechanism for that encapsulator agent to encapsulate the gas, rendering it not flammable, not ignitable. So what we're going to do is, as we add the water, and in here there's probably, I'm going to say 8, maybe 9 gallons of water. It's definitely more than the 5 gallons. That's, again, minimal. But it just shows that we can't add too much and start to cause a dilution. So in this test, once the solution is made, okay, it's allowed because of some minor frothing that may occur. It's allowed to sit for 1 minute. At the end of a minute, we take a torch and we'll light up the torch and we pass the torch across the entire surface of the pan. We can't have any ignition. There can be no flames. Where it now becomes different than foam is that pan sits for 2 hours. And at the end of 2 hours, where with foam, that foam blanket after, that 2 hour period would break down and expose the fuel. Okay. At the end of 2 hours, we pass the torch across. And once that fuel has been encapsulated, it still cannot ignite. We're doing something a little different here. After we've encapsulated the gasoline, we're going to take some of that encapsulated gasoline and we're going to throw it on the tires. And as you can see, we put the tires out. Another thing to point out, look how rapidly that black smoke kind of disappeared. And we'll talk about that as well. So that's how an encapsulator agent works. We're taking, the flammability out. And it does the same thing when we sit there and we start talking about vapors. And we'll get into that as we go further into the program. So we'll talk about all these different things, that fire suppression, the spill control and remediation, and vapor control, dust control, and things that are basically hazards when we sit there and we start looking at our industrial applications. So the advantages are being able to use it on equipment that's energized. We've got tests that have been done by Con Edison and FDNY that shows that, in energized atmospheres, it can safely be used with proper training and understanding how to use it. Fire protection, decreasing the amount of water. There's many cases where, again, those copious amounts of water that have been discussed being required now can be manageable quantities. For instance, car fires, less than 100 gallons of water, where currently, today, you might use 500, 800, 1,000 gallons of water on a car fire. Using an encapsulator agent in your water stream, you're doing it with much less. In some instances, we have departments saying, hey, we could put a car fire with 20, 30 gallons of water. So again, that much less water, that much less runoff, that much less environmental impact. So we're going to also talk about that less water being needed for these industrial applications, and then how it's able to penetrate into some of the deep-seated fires and the silos and bunkers using specialized equipment. So let's talk about the applications and fire suppression. We'll talk real quickly about the benefits of an encapsulator agent and how it's able to reduce the smoke by improving visibility, how we're able to rapidly reduce temperatures. And not only that, but when we rapidly reduce those temperatures, there will be no steam. Okay, so we're eliminating those chances for firefighters in these applications of getting steam burned. Okay, as far as the fluorine free, huge issue. Many states are banning AFFF or ARAFFF foams for the simple fact because of the PFAS, the PFOS, and the PFOAs, the forever chemicals, as we're calling them, the fluorinated ingredients. We're sitting there and we're going to see how with an encapsulator agent, there are no fluorinated ingredients, and how it's effectively able to extinguish using less water and the benefits. So as I mentioned, being able to cool metal structures, what is a problem with most cases where we have reignition. Okay, if it's in an industrial application, especially tank farms, okay, we might be able to put the flammable liquids out after we're able to create that separation of the fuel and the oxygen. But once that blanket breaks down, if we haven't cooled the metal structures around it, we have reignition. And we'll see that here in a bit. Okay, work safer in combination with other agents. Okay, again, foams, dry chems, we can sit there, we can be used together if, again, we can explain that, how the two work and how they can work together. And then as we go through how we're going to be able to prevent the spread of fire. When we sat there and we saw the videos of those flammable liquids flowing out of a warehouse. Okay, how about we're able to extinguish the fire and prevent that type of incident from occurring again. When we sit there and we start talking about encapsulator agents, like many, but we do reduce the surface tension of water, so it helps it to penetrate deeper into, for instance, bales or paper rolls. And I will talk about that energized environment. So when I talked about those three-dimensional fires, this is a fire that I did a little research on, and it was not, it's probably been about 3-4 years that this occurred down in Deer Park, Texas. And it started out with a manifold fire, or it's believed to have started out with a manifold fire. It's a three-dimensional fire. Foam was not able to extinguish the fire. And just real quick,
Highway 225 is shut down in both directions too. Good evening, I'm Jason Miles, and tonight for Ron Trevino. The chemical fire started about 12 hours ago and is only getting bigger. Stephanie.
So as he said, it started 12 hours ago and it's only getting bigger. And the reason, a three-dimensional fire. And as you can see from the bottom picture, it went many days. It was reported to be extinguished, and then the reports came back that it had started again. As I mentioned, that foam blanket broke down. Those metal tanks were still hot, that reignition, and it went from that one tank that you saw in the news clip to becoming 11 of 15 tanks that were burned up and destroyed in this fire that took days and days. The other hazard, again, all of this mass quantity of water, foam, and I will say fluorinated foam, the containment area around the tank farm failed, and much of this foam and this contaminated water was able to flow out and get into a water system and a water area around the facility, affecting the community. So when we sit there and start looking at your three-dimensional fires, here's an example. This is a simulation of a jet engine cowling. It was done using salt water, a 3% mixture of F500 and the 95 gallon per minute nozzle. When you sit there and you watch him approach, he's going to approach coming in from the left. He sprays the ground looking for a milky white discoloration, making sure that the agent is in the water stream. And then he sits there and he starts aggressively attacking the fire. As you can see, he's going to change his spray pattern on his nozzles because he's trying to do a couple of things. He's trying to interrupt and interfere with that vapor phase where basically the vapors are burning. And he's also working to cool the metal structure, that reignition source. And once he gets that under control, as you can see, 27 seconds, he was able to extinguish that three-dimensional fire. This is another example of a fire. It's a three-dimensional. Again, it's using diesel fuel. It's a plank. This was done with the refinery in Italy. We now are using a 125 gallon per minute nozzle. Again, it's going to be a little bit more difficult of a fire. But again, using foam, we would not be able to extinguish this fire. So I'm going to speed this up here just a little bit as it goes through. As you can see, we give it a pretty decent burn time, let it get good and hot. Again, black smoke is going to start turning white as we start attacking the fire. With foam, I'll mention again the 3 techniques that you can apply. And as you can see, none of those techniques are really going to be able to be effective on a three-dimensional fire. Here he's aggressively fighting this fire. He's working to put it out as he makes sweeps across, putting out the I guess you can say the flames down lower that are a reignition source for the fuel that's flowing down the plank. So he's able to, in 35 seconds, extinguish this fire. We sit there and start thinking about uses in aviation. Okay, I know many instances where there's applications where this could be used. For instance, here we have a support vehicle on the ground that's powered by lithium-ion batteries. Problem becomes those lithium-ion batteries, as they sit there and they start to burn, we're using a dry chem, a powder. Powders are not suitable for extinguishing a lithium-ion battery because they don't do anything to cool or stop thermal runaway. Foam, This is a YouTube video. It's kind of a long one. I've shortened it up just to get, the I guess and say an idea of this. But if you look up and you Google and O'Hare Airport plane crash, if you watch the whole video, and again, I'm not gonna play because it's relatively long, but you have about 8 of the airport crash fire rescue vehicles attacking this fire. And at times you'll see the purple K when they sit there and you go through this video also being sprayed. And it looks like as we go through, I mean, we see a little bit of black smoke, but it looks like we're getting a pretty good handle on this engine fire with all of these trucks and their foam capabilities, mostly trying to attack. But then all of a sudden, here we see the smoke getting a little bit thicker and heavier. We see the little bit of the purple there, purple powder being utilized, trying to extinguish this fire. And as you can see, with all of the foam, all this runoff, and all this, fluorinated, cancer-causing foam that's being utilized by these trucks, they're getting absolutely no place in trying to put this engine fire out. But yet, we just saw with that video of the jet engine cowling in 27 seconds. Okay, using 95 gallons per minute, we were able to extinguish that type of a fire. Still working with them, trying to get with the aviation industry. When we sit there and we look at another instance, this was some testing that was done in China with some above ground storage tanks, large diameter in the province. We're going to go through here, speed up a little bit. When we sit there, we look at this particular test where it was used 574 gallons of diesel fuel. They're using one monitor, using F500 at 3%, and the flow rate is 570 gallons per minute, as you can see. When we start doing the application and they start doing the testing, you'll see here that we have a little bit of that foam knowledge, or a little bit of that foam training that's taking into play, because you'll see on the bottom left, just below that stairway, they're spraying the side of the tank, trying to cool it, trying to get that metal structure cool, so that with foam, you can get a footprint and you can start getting that foam to cover the surface. And here we see that they were able to extinguish that tank with 16.5 gallons of F500, 58 seconds. Pretty impressive when you sit there and start looking at the type of fire that they're dealing with. So now as we go through, we're going to do the test again. We have the same amount of diesel fuel. We're now using an AFFF foam, but we're going to make some changes. We're going to use 2 monitors. We've also got the hose stream on the side of the tank, trying to get that cooling effect going, so that that foam blanket and that foam can sit there and start getting a footprint. And at this time, instead of just one stream, we're using 2 streams trying to cool the side of the tank. Here he's trying to use that monitor nozzle, see if we can't get a little bit of cooling, because again, they understand until they start to cool that tank, as fast as those bubbles hit that hot surface, they're just going to evaporate away, and it's going to be difficult to form a blanket on the surface and be able to extinguish this fire. So as they continue to flow, I'm going to go through here a little bit, speed it up. We're going to continue as we go through with the foam. Like I say, again, 2 nozzles. So it took them 7 minutes and 35 seconds. They used 8,655 gallons of solution, or 260 gallons of concentrate. So when we sit there, we start looking at cost comparisons. Okay, 16.5 gallons versus 260 gallons for the same fire. When we now look at some of the green foams that are coming on the market, the current discussions and some of the reporting is you're going to need 3 to 5 times more of the concentrate, the foam concentrates with the green than the current AFFF. So quickly, if you sit there and you look at 3 to 5 times more, that is quite a bit more foam than the 260 gallons. So when I get into some more, I want to now talk about a major fire that occurred in Germany. Dealt with bathroom fixtures. This happened in Böblingen area, the warehouse, and it was 450 firefighters. Took several days for them, and it started out, as you can see, in an area of the facility. There's plastics, there's many different things, and as this fire started to grow within this area, you see the tube hall and the areas that were affected. Well, they were trying to protect the sanitary storage area, as you see, in the loading zones and things like that. And there were fire walls there. There were fire breaks. So what they did is they set up teams inside to sit there and use F500 at 1% to keep those fire doors cool. And they had some units that were also applying F500 to the roof area. I'm using it to keep it cool and to protect that area. And as they went on, they saw how effective the agent was working and doing and protecting that area, that they finally decided that, well, if it's working so good protecting, what will it do if we start attacking the fire? So they sat there and they turned their efforts on to starting to use it to extinguish the fire, and they started to make some really, really good headway. And they ended up, within a few hours, getting the fire under control and quickly getting it extinguished. So here we have an instant, and this was the largest fire in Böblingen, in that district of Germany, since World War II. So it was a large-scale fire, calling for, again, 450 firefighters and many departments from the surrounding area. And the thing is water supply. And you'll hear that anytime we sit there and we start dealing with the industrial type fire or any type of our large fire with our cities and our communities and areas, is water supply. We have to look for ways to possibly get water, either drafting from lakes or rivers or streams, or getting into, tying into multiple water systems. But water supply can often be a huge issue. Well, again, if we can start adding something into our water that makes a little bit of water seem like it's a lot, if we can make, 1,000 gallons of water seem like it's, 10,000 gallons of water, by adding something to the fire, to the water stream, it can, again, reduce that hazardous water runoff, the effects on the environment, etc. And here we have, tire fires, and some of the largest tire fires that have occurred and have been quickly extinguished, have been extinguished using an encapsulator agent, F500. If you look up, we have Gila River, Arizona, and Watertown, Wisconsin are two of the ones that come to mind. And I know we've had some just recently. Here's the video showing the massive fire that happened at Gila River.
Then 1 million tires go up in flames at a dump just a couple of miles north of Coolidge. You can see it right there on the map. That sent a cloud of smoke thousands of feet into the air. Sky Fox arrived on the scene minutes after it all started. This was the scene around 3:30. Less than 30 minutes later, the second row of tires catch fire, sending even more black smoke into the air. And this was the scene less than 3 hours later, after nearly all of the piles had caught fire.
Dust, rain.
Oops, sorry about that. I'm trying to
get any bigger. Hope number 2 is a second shipment of firefighting foam, originally scheduled to arrive from Georgia at midnight, now expected around 3 a.m.
Firefighters say a foam chemical retardant seems to be helping extinguish the fire, and they are trying to arrange for emergency shipments of more foam and water.
Now, that fire retardant was flown in from Atlanta, Georgia, and trucked up here from Sky Harbor Airport.
And it seemed to have turned the black smoke into white. Then you add more water to it, then it seeps down and puts out the fire.
Well, we're going to show you, Marty and Scott, because it's the third day of this fire, and they have done a lot of work on it.
You can see from up here now there are some piles that are still putting out that black smoke. Some of those piles, though, have changed to putting on a white smoke. The reason for that, they're putting a fire retardant on those. You can see the trucks down there.
That's right. This has been a very difficult fire to fight. But as you look at it right here, you can see fire trucks spraying foam on the fire. They've shipped in 12,000 gallons of a special foam.
This is what the scene looks like right now from Chopper 15's Ultra Cam.
Okay, so as we go through and we watch the video, we hear it referred to as special foam, retardant agent. Again, this was an encapsulator agent. Foams were used, water was used. It started out when departments first arrived with one pile of tires that were on fire. Again, let's think back to that tank farm, starting out with a manifold, then 11 tanks burned. This was the same thing. Started with one pile of tires. The fire department arrives, they try to cool, they try to extinguish, unsuccessfully using water and foam, and it spread to all these tires. F500 encapsulator agent was brought in and was able to quickly bring this fire under control and get a handle on it. Some of the other applications are spill control. When we sit there and we start looking at being able to remediate these flammable liquids, and we'll see also some corrosives. Where foams are, again, making that blanket, okay, it's temporary. Once that blanket breaks down, okay, it's gone. That protection's gone. Does nothing to neutralize. Where we saw in that 7-7 test, we're able to encapsulate. Well, once we encapsulate, we help if we get into the soil, or if the fuel gets into the soil, we help that break down. Okay, we help actually increase the organisms that digest, and so we cause those petroleum products, those hazardous products, to break down faster and safer. And again, we're biodegradable, so we do not stay in the environment when we sit there and start looking at it, unlike the forever chemicals that we're used to using. So the benefits, well, like an encapsulator agent will work in salt water as well. So when we sit there and start looking at uses on ships, on cargo ships, shipping lithium-ion batteries, on oil rigs, platforms, we can sit there and we can be effective in being able to extinguish those fires, and again, safer, using much less water, causing less environmental pollution, less water pollution, etc. So we have to sit there and we look at all the different rules and regulations as far as the encapsulator agent solutions. In most cases, we can allow them, especially when we use them for wash down on soils or on surfaces, we can allow it to evaporate. There's no special cleanup. Where with foams and other absorbents, we do have some type of a remediation that needs to take place. And if we're using our clay type absorbents that will, under pressure, release those petroleum products that we try to absorb, then they have to go to some type of a hazardous waste landfill. Not only that, but there are reignition seals. Here's an example where they're using F500 3%. They've treated 1/2 of this fuel spill. The side that's been treated, as you can see, the fire does not go across. And I'll point out, there's no blanket. You see that milky white discoloration in the water, but there's no blanket that you might be used to seeing with foam. So now he's going to come through and he's going to put out the rest of the fire. He's going to use a little extra just to make certain, again, that milky white discoloration, there's no bubbles. Now the person is going to spark up the torch. He's going to walk through. As he walks through, he pauses for a moment, and to show that there's no blanket to break, he kind of sweeps his foot while the torch is in hand. Again, that fuel, just like we saw in the 7-7 test, has been encapsulated. It's no longer a hazard as far as flammability, so it's made that scene safer. This is an example that was just recently. last year, I believe it was, in Globe, Arizona. Tanker truck carrying 9,000 gallons of gasoline and diesel went off the road and down an embankment. Anyway, the problem became that, here we have a tanker truck that's full of fuel. And in order to really get it back up onto the highway, it has to be offloaded. And because of the way it was and the difficulties, they could not get the bottom valves open so that they could drain using the bottom valves to drain the tank. So the decision was made that they were going to open up the dome covers, and they were going to sit there and they were going to allow the fuel to be drained out as they roll the tank. Here we've got firefighters up there, and they're protecting firefighters using 3%. She's up there to open up those dome covers. And after they got the gas unloaded from it, they were able to, again, under the protection of F500 streams, as they were towing or pulling the vehicle or the tractor trailer up onto the highway, they used F500 to make sure that there would have no sparks or ignition for any residual that might have been left. So in total, they were able to retrieve the truck and trailer in just under 6 hours. Where if this had been other types of products, again, the problem would have been the fire risk and the hazard had they used some other thing, some other extinguishing agent, excuse me. Another case history is from Chile, where there was an acid truck that was involved in an accident. It had 4,000 liters of sulfuric acid that was spilled on the roadway. Using F500, 3% concentration, it was able to be neutralized to a pH of 6 with no exothermic reaction. There was no plume, there was no cloud like you would get if you had used water, or if you sit there and try using other methods to neutralize an acid. There's usually always some type of exothermic reaction, some type of heat generated when you're sitting there and you're doing a neutralization process. Yet when they used F500, they didn't experience that exothermic reaction. They didn't get that cloud. And again, they were able to bring it to a safe pH of 6 as we sat there and we go through here. And this is just showing you some of the applications and how they're sitting there and they're spraying it. So the next thing I want to talk about now, again, that vapor control where I mentioned. If you can name me another water additive that we use in the fire service or with fire control that works with being able to eliminate flammable gases or vapors from causing an explosion or fire. I know that I'm not aware of any. If there were, I'm sure the oil and gas industry would be very interested. And I'm hoping that, with these webinars, we can bring to light that protection that we can bring with our VEEP system. These VEEP systems that we talk about, which are the vapor encapsulation explosion protection systems, when you have your LEL monitors in place, monitoring for those rising LELs, and you start getting into those flammable ranges, those explosive ranges, systems can be activated. And once they're activated, the VEEP system can knock down those flammable vapors, reducing and eliminating the chances for those explosions. So when we sit there and we start looking at some of the things that we've learned from 2007 to 11, the number of fire departments responded to an average of 51,600 fires annually, where flammable gases were identified as the source of ignition. So we do have a lot of history, a lot of cases. Here we have a facility, they have a smoking area remote from, the plant. Yet, here we had an instance where we got some flammable vapors seeping low to the ground. It wasn't the person smoking that caused the fire, though. You'll see the flames come from the bottom of the screen and come across into the area. So it's the flammable vapors were all around that particular area. It just so happened that they also included and went into that area where those gentlemen were supposed to feel safe and be able to, have a break. Again, another example of a vapor explosion, and using the VEEP systems. These are things that can be prevented. How many, when we sit there and we start looking at, the severity of these, how many employees, how many people are we seeing, injured or killed? Sometimes maybe career-ending injuries and these types of accidents that occur. So let's talk now about some of the different spray systems that they come up with. I mean, we've looked at putting sprinkler systems around our tanks to cause some additional protection. And we can see some videos that I've killed the sound so you can hear me. We'll see what they'll do is, here we have, again, a flammable vapor. We throw a flare in there. We've got a water system taking place, and we can see how very ineffective that water system is at being able to extinguish or at least control an explosion or fire from happening. Even though it was flowing, they threw the flare in there, and they were still able to have that fire take off. So now when we sit there, we go into and we now redo the test, and we put a second level of water protection, a second level. We still, cannot stop and prevent that vapor explosion from occurring. However,
Hazard Control Technologies presents 500 Encapsulator Technology. Industrial fires. They're one of the most dangerous aspects of any industry's production. One spark can cripple operations and cost lives. But now, even the biggest fire disasters can be prevented, controlled, and contained. It's possible, thanks to Hazard Control Technologies, Inc., a breakthrough combination industrial vapor encapsulation, explosion prevention, and 3D Class B fire suppression system is now available. By combining HCT's F500 encapsulator agent, flammable liquid vapor encapsulation, and three-dimensional Class B fire suppression capabilities, with our VEEP rotating nozzles, a containment system was designed to control and contain explosive vapors, liquid, and gas fuel fires. Systems are available to cover areas both small and large, from pump transfer stations to loading racks and processing areas. Don't wait for the costly explosion and fire disaster. Prevent it with F500EA VEEP system.
Okay, so we had just saw the videos where they had 2 levels of water protection, and yet we still had the explosion and fire. And then with the VEEP system, again, showing the ability of an encapsulator agent in the water stream to be able to extinguish those fires. Okay, but we'll take it one step farther. Again, with those alarm systems in place that monitor for those explosive gas levels, the system can be activated, and it can actually prevent those fires from ever occurring, those fires and explosions. So we're able to work on those 3-dimensional, not only liquid, but also vapor fires. When we sit there and go to some trainings that are available in dealing with 3-dimensional fires, we'll see that the techniques are, again, just like we saw with that airplane, the O'Hare Airport with the crash fire rescue trucks. They use dual agents, purple K, dry powders. The dry powder is to hopefully be able to work on the 3-dimensional aspect of the fire, while the foam creates the blanket on the surface, causing that separation. And, here is a great picture. The forever chemicals, those carcinogens, those cancer-causing properties, the PFOS and the PFOAs. And, here we have our firefighters totally being covered in these types of hazardous chemicals. When we can sit there and we can use a much friendlier this is a distillation column that was done. Again, this is a mock-up of a well blow-off that was done using F500 3%. As you can see, no special application techniques other than rapidly and aggressively attacking the fire. Okay, and as he sits there and he rapidly and aggressively attacks his fire using an encapsulator agent in the water stream, F500, okay, he's having great success in being able to control and extinguish the fires in all of these different applications. Let's look at, for instance, that manifold that caused that tank farm fire. Again, two things are trying to take place here. Looking at trying to cool that metal, that piping, if it's a hot motor or hot to flange, whatever it might be, being able to cool it so that we can, once we extinguish it, stop the reignition. Your flammable gas again. Another example of encapsulator agent being used on a small above ground storage tank. Another example of now a flammable vapor with a manifold. But, here's some great examples of all the different applications when we sit there and we start dealing with those flammable or combustible gases, as well as liquids. The other thing and some of the other areas where we can help and big time with the electrical industry when we start talking about coal dust, but that's not the only areas. We also have many hazards when we start looking at grain silos. Some other areas with the food industry, there's been instances in the sugar industry where they've had massive explosions. But when we sit there and start looking at these types of things, again, we can sit there and look at the benefits that an encapsulator agent can hopefully bring to protect those facilities. As long as we can sit there and get people to start learning about all the benefits that encapsulator agent brings. When we look at the global data in 2018, it shows 89% of the related deaths occurred from explosions. And when we sit there, we start looking at these incidents and we start looking at some of the case histories and we look at OSHA, there's a lot of information that you can view. You'll see that in many instances, it's not necessarily the initial explosion that causes the deaths and injuries within these facilities, but it's the secondary and tertiary explosions. What happens is the first explosion causes this dust to be shaken loose from beams, rafters, light fixtures, maybe some heating and cooling ducts. But what happens is that primary explosion, that first explosion, shakes that dust loose. And as that dust starts to filter throughout the facility, it catches an ignition source, and then you have a much larger, much bigger, much greater explosion. And those are what are causing many of the deaths and many of the injuries when we sit there and start looking at it. Not only are we causing the deaths in the industry, but the millions and millions of dollars in damage that are done to facilities. And in some cases, like I say, these can be take months and possibly even years to rebuild from the damage that has occurred. Show some video here. Silo, damage done to it.
It's buckling the frame of the superstructure, knocking the tin off the superstructure. There's all kinds of shit. Back car.
Okay, so now you start seeing some of that grain that's coming loose, starting to come out of side of the silo. And as we sit there and this happens, and we sit there and start looking, and all we need is that ignition source, that spark. So now as it falls over, you know, we have a spark from metal, you know, and we have that huge fireball and explosion.
200-foot silos packed with over 2 million bushels of grain. 40 men, 10 of them federal inspectors, were working the second shift in and around the big elevator when it blew. 6 of the dead were found on top of the rubble. Others remained buried beneath it, some under these railroad cars. It's suspected the volatile grain dust was ignited in an underground conveyor unloading grain from the rail cars. Was there any warning that this would happen? Strong, it was heard 70 miles away. Windows in downtown Galveston, a mile away, were shattered. Fire.
So here we have a great example of now, not only do we have many dead, the injury to the facility and the plant, but an explosion that was heard 70 miles away, damage to the local community, houses, you know, places of business. So it's not necessarily just going to affect the facility where the explosion takes place. Can have a huge impact within the community. Here's some testing that was done with coal dust. These are some bunkers, silos that can. Like I say, they can be very, very violent. And when we sit there and we look at the
hazard
the dust,
control technologies,
kill this real quick. The hazard and the flammable properties of the dust. This was some testing that was done with sub-bituminous coal dust using 1% F500. And what we have is we have some of the coal. We have an ignition source, and on the left is water, plain water. And when they hit that coal pile and they, you know, have that dust fly up into the air, gets to that ignition source, okay, we have ignition. But yet when they start using encapsulator agent F500 in the water stream, okay, it changes, and we now no longer have that explosive fire. So we start to do some housekeeping. We start to use, you know, some cleaning. We look for a solution in preventing these types of fires and situations from occurring. Again, encapsulator agents can be very beneficial and helpful in housekeeping and keeping things clean and preventing these types of combustible dust fires from happening. Probably the up and coming and the biggest thing that, you know, we need to be looking at in industry, as well as, you know, us as firefighters, is renewable energy. There's a huge change. I mean, you sit there and start looking at our auto industry. Auto industry is looking to try to convert all of their fleet vehicles or all of their vehicles from gas or diesel to battery powered. We're getting battery powered school buses. We're getting tractor trailers. Our basically our large trucks are going battery. And it doesn't end there. I mean, right now we've got racing cars, boats. The market is constantly changing, and we're finding more and more applications where we're getting into lithium-ion batteries. And one of the things that, you know, the power industry is doing, trying to keep up with it, is they're creating these battery energy storage systems. What they do is during those, you know, peak hours when demand is high, they help supply the demand by using these battery systems. And later on in the evening or at night when demand is reduced, then they use the power that they generate to recharge these batteries. So it's a way for them to meet the high demands and maybe stop those brownouts and the rolling blackouts. But they're trying to keep up, and this is a way that they can do it. It's called power shaving. And when we sit there, we start looking at the hazards of lithium ion batteries. I know I mentioned earlier, we're talking about that water, the runoff, the copious amounts of water, 30,000 gallons for one car. I mean, what is a copious amount of water? The thing is it's not just the lithium ion batteries and the difficulties with being able to extinguish them and the reignition that occurs hours to days later. But what we don't think about is the HF gas that's being released when these batteries burn, the health effects. How about the contaminated water because of the electrolytes that are in these batteries, the hazards that they pose? I mean, we're worried about the foams and the PFOS and the PFOAs, but how about the hazards that are involved in those lithium ion batteries? So when we sit there and start looking at testing that was done, and tests show that encapsulator agents are able to reduce the HF gas that's being released when these batteries burn. When they were doing the testing and they weren't trying to extinguish the batteries, they had lethal levels that were reaching up to 2,600 or just over 2,600 parts per million. And when they sat there and they went in and they started using encapsulator agents to extinguish the same types of batteries, they were able to drop those levels to 37 parts per million, 37.45 parts per million. So it's giving you actually, as it says, about a 10-minute exposure limit, which is 95 parts per million. So it gives you some safety margin if you're trying to get out of a warehouse, you're trying to get out of a building, you're trying to get out of an area where a lithium ion battery is burning and there's an encapsulator system that's offering some type of fire protection. It's giving you a safety margin to be able to escape without possibly having some type of exposures, effects. This was a fire that was in Arizona, and it's not the only one that's happened. We hear them all the time. And one of the things when we sit there and we have to look at these battery energy storage systems is the current way that they're being protected. In most cases, they're using some type of an inerting gas. And these inerting gases do nothing to be able to cool or extinguish or stop thermal runaway. They may be able to, because they take the oxygen out, they may be able to cause the flames to go out, but they haven't done anything to reduce the hazard. So now when the fire department comes along and they open up the doors, or if a maintenance person, whoever it might be, comes along and they open up the doors, and you have that toxic explosive gas inside that energy storage system, once you get that air fuel mixture just right, you're going to have an explosion. And there was an instance where that happened in Arizona, and it injured and caused some severe injuries to firefighters that actually were career ending. So they are potential hazards that encapsulator agents can be very beneficial for. Testing that was shown earlier that dealt with the Kiwa labs for Johnson Controls. This was on behalf of actually our HCT Europe office and Johnson Controls. These tests were done on powders, foams, and F500. Johnson Controls was actually looking for a third-party independent testing on an agent for a customer of theirs. So they tested all the powders they make in the United States and Europe. They tested the foams, again, both US and Europe, against F500. And as you can see, the powders were very ineffective and the foams were very ineffective. But F500 was able to extinguish this fire and extinguish the battery. Where I mentioned earlier, the difference in the HF gas when trying without trying to extinguish the fire up to that 3,400 parts per million, 2,656 parts per million. But when they sat there and they were using F500, the highest they had was the 3745. So there was a great reduction in the amount of HF gas that's being released, being able to control. So when we start looking at some of the other instances with batteries and all the other things, you know, we talk about all the different and the number of incidents. But not only do we have those, but, you know, let's look at our wind turbines. You know, some high hazards. And when these are burning, like I say, you have many different materials that are involved. Again, you've got lubricating oils, you know, the composite materials that make up the blades. And in most cases, the only thing that, you know, your firefighters and things can do is pretty much watch them burn. Again, you know, working with some of these manufacturers, systems could be installed that could offer protection and help prevent these fires from ever occurring, and being able to cool bearings when they start getting overheated. So the big thing with the foams, you mentioned it, and you know, you can't talk about enough, because there's many states that are banning the use of Class B foams. There's some states that have done pickups. They've contacted fire departments and municipalities, and you know, they are basically collecting them. There's some states that are going out and treating the use of a AFFF or an AFFF foam, your Class B foams, your non-green foams, your fluorinated foams. They're treating it like a hazmat incident. So if you go out on an incident, let's say you have a truck rollover or even an auto accident with a fuel spill, and you start using a Class B foam, you need to, in many cases, report that back to your local state has a health department, or in some instances, even the environmental departments within the states. And they're treating it like a hazmat scene. And it all is boiling down to is if you're causing some type of an environmental impact that's going to cause or make some type of an environmental cleanup necessary, who's going to pay the bill? So if it's the fire department that caused that type of a environmental impact, again, it more than likely could end up being a community or a fire department that's going to get a bill for using your fluorinated foams. And I mean, if you're following any of our trade magazines in the fire service, if you watch some different news, I mean, the attorneys are out there with their ads and their articles and different things where if you've been exposed to these types of foams, the fluorinated foams with PFOS and PFOAs, and you have, you know, certain types of cancer, they're looking to basically take you on as a client. There's a huge class action lawsuit, but you need to understand that, you know, these PFOS and PFOAs have been in a lot of other things as well. And while these are only listing the cancers, there are many, many other health effects that exposures to the PFOS and the PFOAs will bring. So when we get into a little bit more, we've talked about that hydrogen fluoride, being able to reduce it. We talk about flammable gases. How about, you know, the toxics, the hydrogen sulfide? Again, it's one of those sensitizing types of chemicals where, you know, you take a sniff and all of a sudden, you know, you smell it briefly and then you don't. But yet your exposures could be deadly because they could still be there. So when we sit there and start looking at these types of toxins, okay, a great example is when we sit there and start watching our videos and we talk about black smoke turning white. I'm going to back that up and play it again from the start. Here we have some tires, and I'm going to stop it again as we sit there and we make our attack. First off, if you look, you'll see he sprays down to the side. You see that milky white discoloration in the water. He sits there and he starts making his attack. As he sits there and he starts hitting these tire fires, where's the smoke? Where are the toxins? Okay. We've had the ability, an encapsulator agent has had the ability to eliminate, reduce those toxins considerably. Okay. That white mist that's coming off there is not steam. If you were to take your glove off and stick your hand in there, it'd be a warm white mist. Here again, is a video. I talked about that sulfuric acid being able to neutralize to a pH of 6. Here's the example. They're using an F500 solution and spraying down that sulfuric acid, and you'll see there is no exothermic reaction. There's no cloud. And what led to the use of F500 on that incident was, as you can see, they've got all of this excavation equipment there. They were trying to bury it, but the moisture in the dirt, in the sand, in the soil that they were using to try to bury the sulfuric acid was causing an exothermic reaction and a huge cloud. And downwind from this particular incident was a prison that, due to COVID, the government in Chile did not want to have to evacuate. So because of some testing that was done with other applications in dealing with sulfuric acid, they knew that F500 would be effective in being able to mitigate this incident. So they brought it in. And as you can see from this video, and again, I'll play it one more time, as they're spraying into this pit with the sulfuric acid, you do not see a plume, you do not see a cloud that's being formed or caused by an exothermic reaction taking place as neutralization of the acid is taking place. So we sit there and we start to get into the foams. We also have to understand that, you know, with foam, we have special applications. Again, there's only 3 application techniques. It's to rain it down, bank it in, or roll it on. When we sit there and start looking at some of these aspirating nozzles, these special tips, okay, we have to worry about walking through, because if we walk through, we destroy the integrity of the blanket. With the tanker truck on the bottom left, okay, if we're sitting there and we're spraying and we're utilizing fire streams and in the tank, and there again is some type of a breach in the tank, and we start filling it up, what are we going to do? I mean, that oil, that diesel, that gas is still going to float on water. So all we're going to do is start displacing and creating what might have been a small fire into a larger fire. So testing and the problem becomes that these fluorinated ingredients are bioaccumulative. So each and every time you are exposed to it, okay, your body accumulates it and you basically do not get rid of it. So we look at, you know, the pollutants, the toxins, and they talk about the Stockholm Convention. And because of that, many of our countries are banning the PFOA, PFOS, PFOAs. We look at the environmental concerns. And again, this is quickly some of the fire publications, the trade magazines, all of the lawyers and everybody trying to sue foam manufacturers, go after foam manufacturers because of health effects. And the health effects are many. While the cancers are the ones that are really making the news, if you get into, I mean, there are many, many more health effects that exposures to the PFOS and PFOAs cause. When we sit and we look at the F500, the encapsulator agent, the environmental advantages, one is we talked and discussed those spills, okay, and some of the different uses. We are on the EPA's National Contingency Plan and listed as a surface washing agent. So if you have those fuel spills on the ground, you know, you have some things that have taken place, okay, F500 can safely be used to mitigate. Unlike the powders, the clay litters, and the other absorbent materials that might, under pressure, release the fuel back into the environment or into the soil, here we have an encapsulator agent that, when it evaporates, it takes the hazardous fuels with them. It's non-corrosive, it's non-hazardous, it's fluorine-free, and there's no PFOS and PFOAs, and it's 100% fully biodegradable. We look at the interruption of the free radical. Okay, and just real quick, we're almost done here. The black smoke, and the reason for the black smoke turning white is we sit there and we start looking at a test that was done by Clemson University using toluene. And what they did is they were looking at three things when they did the test. They were looking at the smoke coming through the column. They were looking at the buildup of soot and then the toxicity of the soot. And when it was done, the test results were that we were able to increase visibility by 68%, reduce the toxicity by 98.6%, where all your carcinogens and your toxins are. Okay, we are able to have that great effect. So getting towards the end, you know, the equipment and the systems that get into the ways that you can use it. There's our quick attack mobile units, our mobile carts. We have some compressed air systems in different sizes. We get into our concentrate control systems and water-driven proportioners that are able to work on multiple risers and protect many areas of a facility or a plant. These are, again, what you might normally see. And then we also have our diamond doser. Our diamond doser, again, is water-driven proportioner, and we have them in fixed units as well as mobile units. So they're very and probably more efficient and effective than many of the systems that are currently out there, and be more than happy to work with you in trying to get those in place. So in closing, this is just a real quick video about our concentrate control systems, how we're able to work on all areas. Well, again, I want to thank you all for taking time out of your day to join us. I hope from the comments, it appears that we've got some good information out to each and all of you again today. I hope that you will take the time to ask any questions that may come up later on. Contact us. You know how to reach out to us. You'll get a copy of this webinar that Hernan will send out to everybody he's got emails for. It's been my pleasure. I look forward to doing more and hopefully getting more information out. It's our mission to make things safer. And by all means, if we can do trainings, if we can do consulting work, and we can assist any of you in any way, contact us. We're here to help. With that, I thank you. Have a good day, good evening, good night, wherever you may be joining us from.